Hey team, welcome to week 6. This is our last week of calculus notes. So contain your excitement. I know, try to reel it in a little bit. Whew. So we're not going to do a whole lot this week. We talked about the disk method and the washer method last week. So we are going to talk about the shell method this week. And the shell method is when we find the volume of a region, which is bounded by the graph of a function and the x-axis over some interval. And if we're finding it around a vertical line, x equals L, we're going to partition the region into cylindrical shells. And x is what we call the thickness variable. And so the shell method is when we're breaking our solid into cylinders. And so we call them shells, which seemed weird to me. But if you think of like a shotgun shell and how it's a cylinder, but it's really thin, that's kind of what we're doing. It's like just these infinite cylinders. So our volume equation is the integral from a to b of 2 pi times the shell radius, which is x minus L, which is whatever your vertical line is, times the shell height, which is your f of x equation, dx. So let's dig in. Our first example says the region enclosed by the x-axis and the parabola y equals f of x equals 3x minus x squared is revolved about the vertical line x equals -1 to generate a solid. We want to find the volume of the solid. So a picture of that, here's our parabola, 3x minus x squared, and we're revolving it around this line, x equals -1. So when that happens, we get this kind of shape. It kind of looks like a jello mold or like a bundt cake. And so the problem with that is if I tried to cut it into washers, it wouldn't really work because those washers kind of change their shape. And so instead, we're going to cut them into like cylinders, kind of like this. So our equation, we're going from 0 to 3. Because if we go out on the x-axis, it goes from 0 to 3. Because that's where my parabola here intersects the x-axis. If I set that equal to 0 and solve, it's 0 to 3. And so then my equation that we just looked at said we take 2 pi, and then it's x minus L. So x minus -1 would be x plus 1, times my equation, 3x minus x squared dx. So when I'm finding that integral, the first thing I'm going to do is FOIL these guys together. So 1 times 3x is 3x. 1 times -x squared is -x squared. X times 3x is positive 3x squared. And x times -x squared is -x cubed. I have some like terms there, so I combine those, and I have 3x plus 2x squared minus x cubed. My 2 pi is just going to chill out front. I'm not going to worry about that. So I'm ready to integrate. The integral of 3x is 3x squared over 2. The integral of 2x squared is 2 times x cubed over 3, minus the integral of x cubed is x to the 4th over 4. And again, that's from 0 to 3. So I know that when I plug in 3, that's going to be 3 squared, 3 cubed, 3 to the 4th. And when I plug in 0, that's all going to 0 out. So that's just going to be 0. So 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. And so that's 27 over 2. 2 times 27 divided by 3 is just 18, and that's going to stay 81/4. And so when I work that all out, I end up getting 2 times pi times 45 over 4, which is 45 pi over 2. So the volume of that weird jello mold bundt cake, whatever you want to think of it as, is 45 pi over 2. Cool. Let's try another one. This one, our region bounded by the curve y equals the square root of x, the x-axis, and the line x equals 4 is revolved about the y-axis to generate a solid. Find the volume of the solid. So here's my graph. There's y equals the square root of x, and we stop it at the line x equals 4. We're revolving it around the y-axis, which is the line x equals 0. So my equation, when I think of this, my radius is just x, because that's how far I'm going out. My height is square root of x. So my equation, I do 2 pi times, since I'm just rotating around the y-axis, that's the line x equals 0. So x minus 0 is just x. And then my height, my f of x, is square root of x. So if I think of that as x to the 1/2, and that's x to the first, I add my exponents when I multiply. 1 plus 1/2 is 3/2. 2 pi is chilling out front. I'm ready to integrate. And so 3/2 plus 1 is 5/2 over 5/2. And so that's like 2x to the 5/2 over 5. So I'm ready to plug in 4. I know if I plug in 0, it's just going to be 0. So 4 to the 5/2. Well, the square root of 4 is 2. 2 to the 5th is 32. Times 2 is 64 over 5. And that whole thing's just 0. So 2 pi times 64 over 5 is 128 pi over 5. So the volume of that guy, when I rotate it around, is going to be 128 pi over 5. One more example. This is actually the exact same problem we just did. We are rotating the curve y equals square root of x, which is bounded by the x-axis and the line x equals 4, but now we're going to revolve it around the x-axis. So this time, instead of going around the y-axis, we're going around the x-axis. And so our cylinders are going this way. Since we're going around the x-axis, y is now our thickness variable. And so now my shell radius is y, and my shell height is 4 minus y squared. So if you think of why that is, since I have this equation, y equals square root of x, I'm going to solve that for x, so it's going to become y squared. But I'm coming all the way out here to 4, and so how thick this is going to be 4 minus whatever that y squared is. So 2 pi times my thickness variable, which is y, and then 4 minus y squared. So I distribute my y, 4y minus y cubed, 2 pi's chilling out front. And that's going to be, when I integrate, 4y squared over 2, y to the 4th over 4. And why is this from 0 to 2? Because we're going on the y-axis. So at 4, the square root of 4 is 2. So I can clean that up a bit. 4y squared over 2 is 2y squared, and that's 1/4 y to the 4th. I know when I plug in my zeros, both of those zero out, so I really just need to plug in 2. So 2 squared is 4 times 2 is 8. 2 to the 4th is 16, divided by 4 is 4. My zeros don't matter. 8 minus 4 is 4, times 2 is 8 pi. So the volume of it, when I rotate around the y-axis, is 8 pi. So that's how the shell method works. Hopefully you feel okay with that. You are now ready for week 6 homework. I think I only put like 5 problems on there, but the last one's kind of a big one. And that is your last homework assignment for Calc. Next week, all we're going to do is the Unit 6 test, and then you will be done with this class forever. So let me know if you have any questions. Work hard, keep it up, and that's it.